this is an address of an electron. What does it mean? So you say that all the four quantum number, all the four quantum numbers, represent all the four quantum numbers give us many information, give us many information about an electron. So we say that all the four quantum numbers, principal quantum number, subsidiary quantum number, spin quantum number, magnetic quantum number, give us many informations about an electrons. So that's why we refer the quantum number as address. Address means that it gives the unique identification of the information that we are sending. Then we say the address of sending a letter means we are giving the unique identification of the destinations where you want to send that letter. So we say that that's why we refer the principal quantum, we refer the quantum number as the address of the electron. Address of what? Of the electron. So that's the point that you should bear in your mind. Okay, the last application of principal quantum number, last application says that quantum numbers are used to determine electronic configuration and atom. So number 3, quantum numbers, quantum numbers are used to determine what is the electronic configuration, which is the next lecture or session 14, electronic configuration of an atom. Okay? Of an atom. So the quantum numbers are used to determine the electronic configurations of an atom. I will teach you in the next lecture, which is lecture 14, how we can use quantum numbers to write the electronic configurations of some of the atoms. Very interesting subject, don't miss it. Because I'll reveal the advanced way of writing electronic configuration which are acceptable. The fundamental that we taught in the O-level, it won't work ahead from now onwards. So what do we say? So we say that the concept, we say that the combination of the concepts of quantum number the combinations of the constant quantum number and the rules, and three rules, okay, and three rules, combinations of the cause of the quantum numbers, and three rules help us to write the advanced electronic configuration of 40 of an atom. So I'll teach you how we combine these two, because I didn't teach you yet three rules. I'll teach you these three rules: alphabet principle, pulse principle, and the Hans rule principle. So there are three principles that you have to combine with the cause of quantum numbers. Then we can write 30 advanced electronic configuration of 40 of an atom. Right? Because it will be advancements of what we have taught you in O-level studies. So let me present one sample of the question in exam. Say this is the example 9. Say that using S, P, D, and F notation to describe the following quantum numbers. Here 5 quantum numbers. I'll teach you how you can answer 2, and 3 will be your homework. So it's example 9, but also it's the homework 13, part of it. Remember that a good teacher leaves homework to the students to try, to test themselves if they have understood what has been taught or not. And if the goodness of this, if it is physical teaching, you might consult the teacher. But the goodness of this digital system, if you fail to solve this, means to solve these homeworks, then you have to watch again a video of that particular lecture, because the answer is taught. So the answer of that question is within the lecture that you have been taught. So n is equal to 6. So n is equal to 6. L is equal to 4. So C, n is equal to 4. L is equal to 3. C, D, n is equal to 3. L is equal to 3. Now L is equal to 2. A, B, C, D, E. Say that n is equal to 5 and L is equal to 4. Okay, so you have 5 questions, there's 6 questions. So we have again the other one, it is n is equal to 3, L is equal to 2, n is equal to 4, L is equal to 3, n is equal to 5, L is equal to 4, n is equal to 4, L is equal to 2. A, B, C, D, E, F. N is equal to 4, L is equal to 2. That's the question we have. Okay. The question states that using S, P, S or P or D or F notation to describe the following quantum numbers. So, my dear student, how can you solve this question? How can you answer? First of all, the starting point, what are we given? We have 4 quantum numbers. Principal quantum numbers, subsidiary quantum number, magnetic quantum number, spin quantum number. So in all of these 6 questions, we'll be given principal quantum number, denoted by N, and the subsidiary quantum number, denoted by L. Right. So let me do, I'll do, this will be your homework. This will be your homework. And then this will be your homework. And this will be your homework. So we'll do 2. One R. N is equal to 1. Subsidiary quantum number will be given 0. First of all, forget about the given subsidiary quantum number. If you want to determine the subsidiary quantum number for the first shell, it's equal to what? 0. So it's right. So what the orbital there? So for this case, here in this in the first shell, we have only one S sub orbital. Because use the notations of that and describe the following quantum number. So it is S. Okay? So you say that N is equal to 1, it has only S sub energy level. So because it is lowercase s, so you can use that it. So you say that its notation is S orbital. So N is equal to 1 is what? Is S. And then so you can say even 1S, because the principal quantum number is equal to 1. But because you've been asked to use S and whatever, so you can leave like that one. Next we have what? C. C, the principal quantum number is equal to 4. Listen carefully. Then how many subsidiary quantum number you can find? 3. 0. L is equal to 0, L is equal to 1, L is equal to 3. And then so we are not given 2. So we'll be given 1. L is equal to 3. Right? So when L is equal to 3, in terms of magnetic quantum number, here we have 7 orbitals. Why? Because negative 3, negative 2, negative 1, 0, positive 1, positive 2, positive 3. So you have how many orbitals? You have 7 orbitals. How many electrons can be accommodated here? 14 electrons can be accommodated. So the notations, because you have L is equal to 3, then here we are going to have what? So which sub-energy level which can have 7 orbitals? How many orbitals does S have? 1 orbital. How many orbitals does P have? 3 orbitals. How many orbitals does D have? 5 orbitals. How many orbitals does F have? 7 orbitals. So this is, so we say that when N is equal to 4, and subsidiary quantum number is equal to 3, then its notation is what? F. Interesting. That's all. Simple. Okay, so I would like to say that this is the end of this longest lecture in atomic structure. I would like to thank God who have prepared me from the beginnings of preparations of this concept, who have taught me when I was in A level, when I've been teaching student physics. So I thank God for everything He has done in me on preparing this material. I thank God also who have given me skills and techniques and tips and different teaching aids to teach you this stuff. I thank God also who have given you opportunity also to learn this material with me. I thank you also for taking your time and learning the beauty of quantum number with me. So I would like to say that this is the end of session or lecture or period 13. Join me in the next lecture, which is period or session or lecture 14, when I will be teaching you about electronic configuration, advanced electronic configuration. In case you have questions, please ask in the comment sections. Don't forget to subscribe so that you'll get notification when you add a new video. And also, Share with your colleagues, with your other students, the pre-Form 5 students. Share this material with O-level students, with A-level students, maybe with Form 5 students, Form 6 students, you see. We see even diploma students, because those who are doing science and are doing chemistry also, they are learning about this stuff. So they are suffering, they are getting confusion. No need for you to get confused while the world is open and the knowledge is there for you to grasp it. So I would like just to ask you that join me in the next lecture. I used to pray for you. I insist you also to pray for me, because this is a huge business. Again, I want just to tell you like this. This is the national program. It's the national programs also, because it's crossing the borders of United Republic of Tanzania. I would like to ask you that please write in the comment sections, where are you when you are learning this material with Olenjolai Moko? So please tell us in which regions, in which district, in which ward, at which school, because we want to know that where we have already reached and where we didn't yet reach. So we can know that how we can tell or inform people of that particular place. Whether you come from Zanzibar, you come from Mwanza, you come from maybe in Kigoma, you are studying in Sumbawanga, you are studying in Beira, in Songwe, in any regions or in any district, please write in the comment section. I think that you just spend 2 to 3 minutes for you to tell us where you are. So thank you very much. May God bless you. Meet you again in the next lecture. See you again.